Alright, hello there, Year 11. We are back in chemistry and we are talking about dilute solutions today. So what you might have come across yesterday when we talked about trying to prepare a standard solution where you have a known mass, we're going to cover that again just as a recap today in case you might have forgotten. But we are also going to look into concepts of what is a dilution and how do we make a dilute reaction or dilute solution. So just to start ourselves off, make sure you write the following questions into your workbook and answer it into your workbook as well. So question 1 says, outline the meaning of the term standard solution. Question 2 says, draw a volumetric flask, pipette, and burette. Okay. If you want to have a go, could you please pause the video here because I'm going to be moving on towards the answers in 5 seconds. Okay, so what is a standard solution? A standard solution is one whose concentration is known accurately. So it's basically when you dissolve some kind of solute into a solvent, and you know exactly how much of that solute is inside that solvent, which is what we call the standard solution here. Draw a volumetric flask, pipette, and burette. This is an example of a volumetric flask. This is a pipette, so pipette, and this is a burette. Okay. These will be very important when it comes to diluting solutions. The ones that we will probably use in Year 11 is the volumetric flask and the pipette. The burette comes more in Year 12. Alright, so what dot points are we covering? We are looking at the molarity formula, so C equals to N over V. And we're going to also look at dilutions. Now, if you read this statement closely with the syllabus, it says dilution says the number of moles before dilution equals to the number of moles of sample after dilution. Now, what does that mean? That's what we're going to look at. Remember, this is your relevant textbook chapter, so have a look at that, all the pages. Now, yesterday we talked about preparing a standard solution. So this is how we're going to do it. Step 1, you are going to have a pure solid and you're going to weigh it on the electronic balance. Okay, and we're going to use the formula. I'll just write on the screen here. We're going to use the formula N equals to M over NN. MM, sorry. And that's going to help us work out how many moles of that product do we have or reactant do we have at the start. And that's the solute we have. Next step is to transfer the substance, so transferring our solute. So now we're transferring our solute into our volumetric flask. You can then wash it with distilled water and then you pour it in. Now, if you have any little bits of solute left in the beaker, remember you need to pour it using the distilled water to get as much out as possible. And for those who ever wondered, do not drink distilled water. It doesn't taste very nice. Question 4, or not question 4, sorry, but statement number 4 is to dissolve the substance in water. So this step we have here. From step 3 to step 4, you'll have a little bottle cap on top. Place that little bottle cap on top, and what you'll do is holding the top of that bottle with your thumb, and then your fingers holding the neck. So if I have my fingers wrapped around and then my sort of thumb on top, looks really awkward, but like that. Invert it, so invert it up, down. You don't need to shake it. If you shake it, you might have everything spill all over you, so I recommend just invert it a couple of times, and once you see no more solids, then you know it's completely dissolved. Once you've done, add water all the way to the line. Make sure that the meniscus is just touching the line on the volumetric flask. If you do struggle with the final few drops, you can use a plastic pipette, the little droppers, and that can help you out that way. So be a little bit more stress-free. So if I summarize these into actual steps, step 1 when preparing a standard solution, you're going to have whatever substance you're going to use, you're going to put it on an electronic balance and you're going to record the weight. Now for accurate weights, we'll try and avoid using weights that go to only 1 decimal point. We'll try and use up to 3 decimal points, okay? So that's how we ensure it's really more accurate. These are the standard ones that you'd find in high school. Now, if you go to uni, the measuring tools are way more in-depth and way more precise. And they go from 4 decimal points to even 5 decimal points at times. So step 1, measure the mass of the solute accurately by placing it on an electronic balance. The ones that we have is the top loading balance. Most unis use like the analytical ones, but we do have some at high school as well. Step 2 is to prepare a standard solution. So like I said, what you do is you pour in your solid into the volumetric flask. You can use a funnel in case you spill any solids over. What you then do is use your little squishy bottle of distilled water. You're going to pour that water into the beaker. And you're going to try and rinse it all the way through. You can use a filter funnel to ensure that none of this splashes anywhere. But the final step after you've washed everything out of the beaker is to also ensure you've washed everything out of the filter funnel. If you have a look down here, it says deionized water. Deionized water is the same thing as distilled water. So the exact same thing. Essentially, it's water without any ions, so no calcium, no magnesium, none of the minerals. And then once you're done dissolving everything, fill it up all the way to the line here. You can gently swirl, but you try and invert it. And the mark to show you where you should be stopping is this bit here. Notice, as you can see, some of the liquid has gone over the line, but we determined that to have an accurate measurement of volume, the meniscus at this line here is just touching, and that's when we know we have an accurate measurement of volume. To avoid a thing called the parallax error, which is essentially looking at the volumetric flask at different angles, giving you different interpretation of where the meniscus is to the line, put yourself at eye level to this little line here, and that should avoid you getting any parallax error. So just make sure your eyes nice and close at eye level, or doesn't need to be close, but at eye level looking at this line here. For those of you who might be wondering why the meniscus is shaped like this, that's just to do with surface tension of the liquid. It likes to stick onto the surfaces. If you have liquid mercury, it actually is in the opposite direction. So with liquid mercury, the meniscus kind of goes like a concave up rather than what we have here. Should be convex, sorry. Next bit is, these are just the standard steps. So if you do need to, I'd suggest you copy this down into your book. But it says, use the chemical formula of the primary standard to determine the molar mass of the compound. So, like I said, if you go with this, I'll just change to my writing pen. So firstly, you need to find out the molar mass. So you're using N equals to M over MM. Little m is the thing that you measured out. So whatever you measured out with your electronic balance, that's the thing that you're going to put up there. Remember, all of these are in grams. That's in grams. That's in grams per mole, which means number of moles, the units of that is just moles. Molar mass, you can find that on your periodic table, so make sure you use your periodic table for any of these calculations. Step 2, it says use the mass and molar mass of the primary standard. So the very first standard you use, to determine the amount in moles dissolved in the volumetric flask. Okay? So that is, again, just this bit over here. This bit at the top, you're just trying to work out the molar mass first. Then last step, use the amount in moles of the primary standard and the volume of the flask to determine the concentration of the standard solution. So that goes to the molarity formula. So that's our molarity formula. And that is C equals to N over V. Remember, concentration molarity is moles per a liter. If you're not sure, I do suggest you to go back to the previous video, as it will give you a bit more explanation of what the molarity formula is. This is just a little simulation depiction of what dilution is. So what is actually happening here? Okay, so we say something is concentrated if there is way more solute in comparison to solvent. If I slowly increase it, let's say now it's a 1-to-1 ratio between the solute and the solvent. It's no longer concentrated. But if I continue to increase the amount of solvent I put in, my solutes are now going to disperse further and further away from each other, and now the solution is diluted. So we're saying it's diluted when there's way more solvents than there is solutes. Okay? The other thing you might take notice of is we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, let's just say particles. Let's say if we then dilute our solutions, how many particles do we have left? So after the complete dilution, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 particles again. So let me just write that down for you. So the number of moles, so number of moles when it was concentrated, say it was 15 particles or 15 moles, okay, 15 particles. After dilution, we still have 15 particles. So what does that tell us? It tells us that the value N does not change in a dilution. Okay, so the value for N doesn't actually change, and that actually becomes really important when we're trying to perform our calculations, as it makes life a lot easier for us, because we're not trying to calculate a new number of moles. Just to demonstrate again what I mean with dilution, if I just switch to my simulation here. So I have my solvent, which is just water. If I then put my concentration in, remember, if we're looking at molarity, it's moles per liter. If I throw in my solids or my solute, I have a certain amount of concentration now. Remember, the amount of solute that I've put in has not changed, even if I try and add more solvent. Okay, so I still have the same amount of stuff that's being dissolved in the, let's say, the water. But my concentration does change because I now have a lot more liquid for this solid to move around. If I reduce the amount of solvent, okay, if I reduce the amount of solvent, all right, it wouldn't do anything here because obviously it's the same concentration still. I'm leaking as much solvent out as solute. If I want to make this more concentrated, okay, one way is to add more solute. That's one way of increasing concentration. of a solution. The other way is evaporating the solvent. If I evaporate the solvent, okay, that's also increasing concentration. Okay, and then we have a point called saturation. When when a solution has reached saturation, that's when you actually start seeing the individual solvents coming back out again. So if I pump this back up, increase that, as you can see, concentration is decreasing quite a bit. And so again, I am diluting that solution. All right, moving back on. So just a definition of what it is for diluting solutions. If the volume of a solution is increased through dilution, your volume, V, will increase, but the number of moles will stay the same. As you can see, the same number of particles remain before and after a dilution. However, because V has changed and N has stayed the same, concentration will have to balance itself out. Why do I say that? For those who are entwined to understanding their maths formulas, the formula we have here is N equals to C times V. So if N stays the same, it doesn't change, and V has been increased, then the only way mathematically N can stay the same is if C decreases or concentration decreases. Next step is how do you actually perform a dilution? I will try and see if I can make another video of a dilution process, but if I can't, you can always search it up on YouTube. So dilution is very simple. You use a pipette and you extract your stock solution. Your stock solution is another way of saying the solution that has been known. So you can also call this the standard solution, as we called before. So the standard solution or the stock solution is basically anything or any solution that you know the concentration of. So it means the same thing. Okay? You're going to use your volumetric flask and you're going to extract up to a certain amount. Let's say this is 25 milliliters in volume. It'll also have a little mark similar to your burette, and you'll also have to measure the meniscus to a point where it's just touching the line there. Now this one is probably a bit more difficult to do because you'll need to extract it quite accurately. If you do overshoot it, you will have to let some of that liquid go, and then you'll have to make sure you get back to that mark later on. But I'll show you exactly what it is or what's it like to use a volumetric pipette. You then pour the stock solution in a separate volumetric flask. The solvent you use, again, you're using distilled water. You're going to use distilled water and fill it up to the mark where the meniscus is just touching the line. Once you've done that, you have performed your dilution. Okay, so that's how you perform a dilution physically. Scientifically speaking, or in terms of the mass of how do you know what magnitude of dilution you want to perform, this is where the formulas come in handy next. If you do want to look at how to perform a dilution, I highly recommend looking at this video here as they go through a nice little explanation. Okay, so the relevant calculations in working out how to dilute a standard solution. We know that the amount of solute has not changed. So N1 of where we were starting will still be the same as N2. So N1 is the original standard solution. N2 is the solution that we've diluted. These two N's stay the same. Okay? So that's what we want to say. N1 is equal to N2. And we also know, as I alluded to earlier, N is equal to CV. Okay? So if both of these are equal to each other, I can just write a broader equation. C1 V1 equals to C2 V2. C1 is the concentration of the first solution. V1 is the volume of the first solution. C2 is the volume of our diluted solution. And V2 is the volume of our diluted solution. So here we have concentration and volume of standard solution. You could put it as any of these numbers, but let's just say number 1 is the one we originally had. And on this side, we have the concentration and the volume of the diluted solution. Okay. If I want to find the new solution, say I want to find C2, I'd move V2 over. The best way to do it is divide both sides by V2. And I'm left with this formula here. So C2 equals to C1 V1 over V2. Don't forget, because this is a concentration calculation, so the units we use is moles per a liter.